So today's topic is about potential energy of a system of charges. Okay. Now we have Q1 charge and Q2 charge, and this is a reference point. The distance from this reference point to Q1 is R1. The distance from this reference point P to Q2. Usually this will be taken as origin. Okay. So the idea is, so this is origin. So you have a point here, charge q1, the distance we know r1, and another point q2, the distance we know r2, and the distance between q1 and q2 is r. Now first initially assume that we are bringing a unit positive charge from infinity to this point. So how we got this point? It is a test charge, unit positive charge from infinity we are bringing here. We don't have any force, opposition force, repulsive or attractive force, because it is only one unit charge, so it doesn't have any force. So just we are bringing from infinity to this point. But if we have some positive potential, then we have repulsive force like that. Now there is no counter force. That means the positive charge infinity is brought down to here. So in that case, what will happen is, we are bringing from infinity to this point q1, and the reference point we have here as P. So in that case, the potential at this point is equal to 1 by 4 pi epsilon naught. Q1 is the charge, and the distance between the reference point P and Q1 is R1P. Okay. Now case 2. Now we have brought one positive charge here. Now we are bringing one more positive charge from infinity to this point. So what will happen? Because of this positive charge, there will be electric flux all around, and this will see a repulsive force. As it progresses slowly towards Q1, it experiences a repulsive force. For the first case, there is no repulsive force because it is the first one. But when you bring another charge q2 from infinity to this point, it experiences a repulsive force, and the work done is against this repulsive force. That's the idea. So work done on q2 is nothing but the charge q2 into potential at r2 due to q1. That is, this charge is brought from infinity and it experiences a repulsive force. So a work has to be done in bringing charge q2 from infinity to this point. So what we have work done on q2, because of this charge q1 is equal to q2 into potential at r2, this distance is r2 due to q1. So what we have, the potential because of q1 is 1 by 4 pi epsilon naught q1 divided by the distance r1p. Actually this distance is r1p. Okay. Therefore 1 by 4 pi epsilon naught q1 q2 divided by that distance. That means in summation, what we try to tell is the work done on q2 is equal to the product of charges q1 into q2 divided by the distance r, and of course we have the constant of proportionality k, which is 1 divided by 4 pi epsilon naught. That is, in short, if you have two charges and if you know the distance between them, work done on the charge q2 is equal to 1 by 4 pi epsilon naught q1 q2, that is product of charges divided by distance. Okay. Therefore we can write, therefore potential energy of system of two charges, if you considering two charges q1 and q2, which is equal to the potential energy is given by U, which is equal to 1 by 4 pi epsilon naught q1 q2 divided by r. Now we will see what will happen if there is more than two charges. Now we will consider more than two charges. Here we are considering three charges q1, q2 and q3. The distance between q1 and q2 is r1, q1 and q3 is r2, and q2 and q3 is r3. Okay. Now for each charge Q1, Q3 and Q2. Now if we consider Q2 and Q1, so we know the work done, which is 1 by 4 pi epsilon naught product of the charges Q1, Q2 divided by the resistance R1. If we consider Q and Q3, product of the charges Q1, Q3 divided by the distance R2. Q2, Q3 or Q3, Q2 divided by R3. And in all these terms, we have 1 by 4 pi epsilon naught as the common term. So we can pull the term outside. Suppose you have 4 charges, 5 charges, any number of charges. What you have to know is product of the two charges divided by the distance. If you know that, you can always calculate the work done or potential energy of system of multiple charges. Okay. Now here the important point here is, for each case it depends on the product of charges and inversely proportional to the distance. Okay. Therefore, you all know already, if the distance increases, the energy, potential energy decreases. Therefore, we conclude that the basic first point we have to consider is the very first charge that is carried from infinity to a particular point does not face any repulsive, any kind of force, just it travels from infinity to that point. But any other charges we try to add upon on the space, then it will see repulsive or attractive force. That depends. So in conclusion, potential energy of system of multiple charges, here we have considered only 3, but we can have n number of charges, is U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R1 plus Q1 Q3 by R2 plus Q2 Q3 divided by R3. That's all about potential energy of a system of charges. Thank you. Nandri.